Okay, good morning all, teachers, faculty, parents, guardian and students. Warm welcome to all in this webinar. Uh, we are conducting this webinar in such a pandemic situation, and it is organized by the Department of Civil Engineering, JP University of Engineering and Technology, Guna. As we know, the social standard of mankind have been greatly improved by the application of engineering knowledge in solving the society's problem during the last few decades. The development in civil engineering has contributed immensely in achieving these standards. You may also aware of that next 20 years will be the age of infrastructure development, especially for the country like India. According to a report, India's infrastructure will require investment of about more than 60 lakh crore rupees in the coming 5-6 years. The goal of this workshop is to provide an overview of civil engineering, various dimensions of civil engineering, the role of a civil engineering and opportunities, challenges in this area to choose this profession, and for those who would love to build career in this field. Of course, this will come when you hear or look someone who is working in this area, or you will come across a situation where the application of all the civil engineering infrastructure uh, will be seen. I hope the whole session will be intensive and productive to see all these aspects. I request you all to make this session interactive either through the chat box or formal interactions. You will be given chance to ask your queries after the speakers talk. Also, you may communicate us through the mail also. I also hope that this workshop will definitely help you to choose such a fundamental yet enthusiastic branch as your career. You may also get familiar with the real challenges of the field. Of course, a little bit who are dreaming to be a successful civil engineer. It will also give you opportunity to understand the endless extent of infrastructure development. The development means not only to construct or develop, rather to make it sustainable under all possible conditions. And this sustainable construction brings new opportunities and scope to civil engineering. With these words, I again welcome you all for this fruitful 1 hour webinar. Now, uh, before I hand over the session to our today's speaker, Shri Rajesh Shukla, uh, I would like to give you a small scope regarding the civil engineering. What the civil engineering is, how we can define the civil engineering, and what is the meaning of civil engineering. As you know, or many of you know, that the civil engineering is the oldest branch of the engineering, and that is why it is called the mother branch of all the engineering branch, which has grown right from the stone age of civilization. That is the fact. And therefore, the American Society of the Civil Engineers defines civil engineering as a profession in which the knowledge of the mathematical and physical sciences gained from study is applied with judgment to develop ways to utilize economically the material and other resources for the progressive well-being of the man. Now, dear students, teachers, and other participants, till now you have seen, you have gone through your regular academic things up to the +2 level. You have studied the basic science courses, including the physics, mathematics, and other courses. But how you can apply those things in the civil application, civil engineering application, that you have to understand and that you have to know before exploring this particular branch of engineering. Now, since the civil engineering is not only limited with up to the construction only, rather it is explored up to the maintenance and its sustainability, right? And when the sustainability and the maintenance comes, it opens the new scope to all the civil engineers. as day by day the requirement of sustainability of any structure, it may be a building, it may be a bridge, or it may be a multi-story building, it may be a highway, it may be a railway track, anything that requires a regular maintenance and upgradation. And that maintenance and upgradation will bring you the new challenges. At the same time, it brings you the opportunities also. So as you see on the screen, we have the various dimension of the civil engineering, that is surveying and leveling, building planning and construction, advanced construction, structural engineering, geotechnical engineering, water resources engineering, transportation engineering, environmental engineering, town planning. Now these are the various dimensions where you can apply your theoretical knowledge of what you have till date, regarding the science knowledge, regarding the mathematics knowledge, but at the same time it requires a practical approach of a civil engineer. Like surveying and leveling is an application of mathematics. It can't be solved without the help of mathematics. But though at the same time, you must know the principle of civil engineering for doing the surveying and leveling. Before any construction, one has to do the surveying and leveling work. Similarly, the other aspects like building, planning and construction, it requires a little management skill, the proper designing and the handling of the material. So all those will be the part of the mathematics and science. Similarly, the other things, the advanced construction. Now this is the thing, that is what I want to refer, is the part which brings you the which brings the large amount of scope in this area, because the advanced construction never ends, and it every time it requires a lot of modifications and require much more skill, or the renovation of a particular type of existing structure. So the advancement in the design, advancement in the material, advancement in the technology, all will be the dimensions of the civil engineering, and it is applied to all types of civil engineering, that may be including with surveying, that may include the building planning, structural engineering, the geotechnical engineering, in every aspect, right?
Yep.
Again, the same thing is represented here, like the civil engineering not only is a engineering, rather it involves the application of basic physics, that is nothing but we call it as a engineering mechanics. It includes, of course, the basic sciences like chemistry, physics, the earth science, life science, etc. The written skill of a civil engineering. So all this will comprise the whole civil engineering, and therefore it requires a skill that one has to develop before applying his knowledge on the field. So what I want to convey here is, whatever you have studied till now, you can apply, you can utilize your all the knowledge in terms of the computer skill what you have, the mathematics, science, the other knowledge to the civil engineering, because civil engineering includes all the types of all types of such skills. Because the civil engineering includes not only the civil engineering, it includes the large quantity of computer applications as well. So as a civil engineer, or as an infrastructure, for the purpose of infrastructure development, we have to think, we have to see all those aspects, like the construction of roads, railways, ports, harbors, airports. These are the parts of the construction of construction of civil engineering. The construction of dams, proper utilization of water resources, construction of housing, commercial and industrial complexes, maintenance of facility, rebuilding, rehabilitation, retrofitting and repair. Now these terms may be new to you, like the rebuilding, rehabilitation, retrofitting and repair. That is what I want to focus. These are the things which creates the future scope and the opportunities to all the civil engineering. The construction is the one phase of the civil engineering, but to make it to make it a sustainable, we need all those things like retrofitting, repair, rehabilitation. These are the important component for a civil engineer. And with the development of the technology, of course, the construction way, the construction techniques requires more skill, and the new process of handling the material and carrying out the construction projects. Now, at the same time, I just want to tell about you about the JP University of Engineering and Technology, the role of JP University of Engineering and Technology in the area of civil engineering. This is the few points which I highlighted, how we are fulfilling the present demand for the building of, for the nation building and for the social benefit. We have a well-equipped department, and till date approximately 900 civil engineering students are passed out from BTech, MTech and PhD. And our department is equipped with the state-of-art laboratories. We are following the CBCS system from the third semester onwards. The CBCS system is nothing but the choice-based credit system in which the student have the freedom to choose the subjects of their own choices based on the field of the area of the interest. And this is the requirement of the present industrial fulfillment. Similarly, we allow all the students to undergo the 6-week industrial training after the third year, so that they can get exposed with the field challenges, field opportunities and field conditions. In that training work, a student has to interact with the engineers, with the designers, with the laborers as well, because when the student will go on the field after completing their degree, they will have to interact from the management up to the lower level. So in that way, the student have to understand how to deal with all those category of the peoples for the execution, for the successful completion or execution of the work. Similarly, we have the well qualified and experienced faculties from IITs and NITs. We also have recently developed the Win Center facility, which is supported and developed by our JP group. Win Center is a facility in which there is a large wind tunnel available, which is being used by the BTech, MTech and PhD scholars for their study and research. Though it is not open for the consultancy and testing works, but at the same time it is used by our student for the study and research purpose. And this facility is being used to analyze the behavior of high-rise building, the bridges, the cooling towers, because those things are having a structure which is very much significant upon the effect of the moving air. So on these structures, the effect of wind is very much significant. In order to check their stability, their perfect designing, etc., we should have such kind of facility, so that a designer can ensure himself that the particular structure is designed properly. And that is why this wind center facility is developed, which is developed by an investment of almost 25 crore rupees till now. And we are at the stage of carrying out the consultancy and projects also by using this facility. We also have a separate cement research lab, that is CRDC, Cement Research and Development Center, in which specifically The chemical physical properties of the cement is studied and tested, and it is then verified for its further use in the field. We are also carrying out lot of consultancy and testing works in this CRDC lab, in which first the cement and its quality is verified, checked out, and then it is proposed for the utilization in the field. And of course, these studies are carried out on the basis of the various codal provisions that are provided by the government and which is written in the code that can be utilized and applied, and result is then evaluated on that basis. As I referred, the consultancy and sponsored work is the one can assume that one can say that it is the core part of the civil engineering department, because through them only, from that only, the department will come across the industrial requirement, industrial demand, and the fulfillment of field problems and issues. So a student can come across lively on these issues during his study at the BTech, MTech, and PhD level through these consultancy and sponsored projects. Many times a field visit or those such kind of projects may be shown or may be exposed to the students also for their understanding and expertise in these areas. We are also running the MTech and PhD courses with the BTech as well. We have almost all branches of MTech like construction management, geotechnical engineering, water resource engineering, environmental engineering, etc. And of course, PhD is also open for all specialization along with the BTech. And also there is an door for the diploma passed out student who can get admitted directly in the second year on the basis of completion of their diploma in the civil engineering or maybe in environmental engineering. So the department is, I think, the department is very well having very well state of art laboratories, the very good faculties, the other resources, the financial support, the management support, etc., for carrying out the study, research, and consultancy work. All this is the brief detail about the JUT University and its status. It is the topmost private university of Madhya Pradesh, which is established under Madhya Pradesh Private University Sthapna Avam Sanchalan Sanshodhan Adhiniyam in year 2015. And the university is approved by the UGC and it is accredited with A grade by the NAC, which is a committee formed by the government, which grades the university on the basis of the teaching learning process, on the basis of research, on the basis of the lab facilities, on the basis of consultancies, projects, and we are fortunately got the A grade by in the very first round of the NAC visit. The JUT also ranked among the India's top private university by the survey done by Seasonal magazine in year 2015. University inspected and approved by a team of experts from UGC and AICTE. I want to tell you the UGC and AICTE teams are regularly visiting our university facilities, its development, and looking after the next 5-year plan, etc. And on the basis of that, they grade the university and examine the university. So there is a regular process of visiting by the experts from the UGC and AICTE, which is the technical society to grade the university. We also have an association. We have a membership of the Association of Indian Universities. There is an association in India of the good university, top level university, and we have the one of the member of that association of the university. So this was a small detail about the university, and these are the official media account web pages from where you can get much more detail about the university, or you can go through the various university activities that we are conducting on the regular basis. Apart from the academics, our university is also involved in the extracurricular activities. We are hosting the extracurricular activities for the students. We are also involved in the social activities to the nearby areas. You will get all those details through this Facebook, Twitter account, on the Instagram account, and you will get the details about all such activities, right? So I think this was the small introduction about the today's event and about the JUT University. So now I would like to invite Mr. Rajat Shukla, who is a alumni of this JUAT, and he has passed out BTech in year 2010. Presently, he is working in Dubai in the company WSP with almost 10 years. He did his BTech in 2010. Then after, he had joined MTech in Delhi Technical University and completed in year 2014 with his specialization in structural engineering. He worked in the field of structural engineering, having good knowledge of RCC as well as steel structures. He had been involved in various projects of residential, commercial, mixed-use buildings and various structures of different occupancies, both in UAE and in India. He worked for different clients. I mean to say the number of clients like ABV Rock Group Company Limited, Cinepolis, Vox Town Square Cinema, Middle East External Customers, Foster and Partners Limited, ASF Groups, RPS Groups, and many more. Now his expertise includes the project planning, project management, design work, and the execution of whole civil engineering project. So with this, I would like to invite Shri Rajat Shukla to share his view, to share his journey after passing out from JUT, how he cope up with the present demand of the market, how he excel his career, and how he has reached to this stage. So with this, I hand over session to Shri Rajat Shukla.
Thank you, sir. Am I audible?
Yeah.
Yeah. Thank you. Thanks a lot, sir. Thanks a lot. First of all, I'd like to thank you for giving me this opportunity to interact with the upcoming students in the colleges, and I wish all the students all the very best. And this is also a very good morning from here in Dubai. I will first start sharing my screen. What I will try and do is I have prepared a small slide so that I can give you a brief of what civil engineering is, and I will also try and give my own experience, my own journey, as Gandhi sir said, and I will try and give my own example and try and talk about civil engineering as a whole. So I hope my screen is visible to everyone. So I have prepared a small set of slides in which I'll talk about myself, about civil engineering and its disciplines, and I'll also talk about what are the scopes in these various disciplines in the given time, and then what did I learn from JUT, why should a person join civil engineering, and if time permits, then we can have a question and answer session as well. So moving on. About myself, I'm from Varanasi in India, in UP. I did my 12th in 2006 and completed my BTech in civil engineering in 2010, as Gandhi sir just said. I got two campus placements from JUET. One was in the Infosys company, the software company, and the other one was in JMC projects of the Kalpataru group. And I got my first posting in Bangalore Metro. I still remember it was Ban Shankari station. I think that station is now running. I was one of the site engineers in piling division over there. But then I shifted. I had this this passion of structural engineering and structural design. I'll come to that in the later part of my slides. So I thought that maybe site engineering is not is not for me. And because whenever I used to look at drawings, I used to think, okay, where is the force transfer and how did they come up with these steels? And so I already had that knack in me. So I then shifted to this small engineering consultancy in Delhi called Seacon Engineering in 2010 itself, after 3 months. And how did I make this shift? JUET has a very strong role in this as well. So that's why I am specifically talking about this. And I'll come to this in the later stages when I have gone through my slides, so that you'll be in a better position to understand what I'm trying to say. But so that's how it started. I went to a site as a piling engineer, and then I shifted to design engineer in the same year, and then I continued in the same firm for around 4 years. During that time, I also completed my MTech from Delhi College of Engineering, or they now call it DTU, Delhi Technological University. So I did my part-time MTech from there, which was with office. So I used to go to college and office at the same time. It was a bit hectic, but I'm really thankful that I was able to do it now. And then when my MTech got finished, I got a chance to come into this company called WSP. Now I'll talk a bit about WSP also, so that you get an idea of what's happening. So I joined WSP Noida office in 2014 September, and then and the WSP Noida office has a lot of, it's like IT offshoring. Like they do, like India is one of the pioneers in doing IT jobs for the various other countries. Now India is also doing a lot of civil engineering design jobs for other countries. For example, our WSP office in Noida, we are doing engineering consultancies for Sweden, for US, for UK, for Middle East, for South Africa, for Canada, for Singapore, for Australia. So, we have around 700, 800 staff over there who are working for different countries. And I got a chance to work for Middle East when I joined. And then thankfully, I also got a chance to shift to the main headquarters of our Middle East office, which is here in Dubai. And that's where I'm working today after 2017 March. Uh, uh, and also, please, if you have any questions, please keep them for the end of the slides. Moving further, I'll just, a small overview about WSP. So this is the world map. And all these red dots are our offices. So as you can see, we have a number of offices in US, UK. We have some offices in Africa, some offices in South America, Australia, and even in Hong Kong and Thailand and these countries also. So we have around 50,000 staff globally, and our headquarters is in Canada, in Montreal. And we are the second, or I think third this year. We are third largest engineering consultancy in the world. So ahead of us is AECOM and I think Jacobs, or Jacobs and AECOM. It's like that. So these are why I'm taking these names, guys, is because I know when I was in 12th standard. In fact, when I was in engineering, I didn't know that these companies existed. And what happens is the civil engineering companies, they are usually like, they are very specialized companies. They are big, but the normal people don't know about it. So that's why I'm taking these names, so that you know that there is a lot of things happening beside Amazon and beside Tesla and these things. We, even in civil engineering, there are big names who are doing great job, and we are proud of what we are doing. It's just that not much people know about it. So, but that's how it is. I mean, that's how our profession goes. But that's fine. But if you are keen on joining in civil engineering, I'm just trying to give you an overview of that. So this is about the total number of offices we have around the globe. And then since I am working in the Middle East part, these are the countries that we cover in Middle East. We have our CRC, we call it, our off-site office in Delhi, where we have a staff of around 80 people who are working for Middle East. I think 200 people who are working for Middle East. And we cover all these countries. And if you see here, this here is United Arab Emirates, where I'm sitting right now, trying to give you an overview. So Middle East business has around 2,000 employees, and we are one of the pioneer consultants in this region. And we have done a lot of work in Dubai. I'm just trying to show you some of these projects. So this is the Jumeirah Gate. If any one of you has had a chance to visit Dubai in the recent past, you can see this fine structure coming up. This is around 380 meters in height. This has now changed the whole landscape of this beach. This is called JBR Walk. And this is one of the buildings that we have recently finished. It's not still open for people, but the facade has come in place. This is another iconic structure called Royal Atlantis. This is Royal Atlantis Phase 2. There is also Royal Atlantis Phase 1. This is sitting right in the center of the Palm Jumeirah. This is another brilliant structure that we have done. So can you guys see my slide? Yeah. So, and then this is another tower that we are doing. This is DMCC tower, and this is also around 385 meters tall, more than 1200 feet high. And I got a chance to work on this DMCC tower and the A4B4 tower. These two towers are coming right beside the esteemed Burj Khalifa. These two towers are also around 350 meters high, and I got a chance to work on one of these towers. So this is just to tell you the kind of work we are doing and the kind of work a civil engineer or a structural engineer does. So with these examples, I'll try and move to the various aspects of civil engineering. Is my slide?
Share your screen.
Screen is gone? Okay, no problem.
Okay. It is visible.
Yeah, I got. Were you able to see the buildings or no? Yeah, so these were the structures that I was talking about. I hope you were able to see these structures. This is the DMCC tower. These are the A4B4 towers right beside Burj Khalifa. This is the Royal Atlantis Phase 2. This is 44 stories high, and this is one of the best structures we've done so far. This is Jumeirah Gate on the JBR Walk area. Moving further, I'll just try and brief because I know most of us know civil. I mean, when we say civil engineering, we know that civil engineer is the one who is doing, buildings, roads, highways, dams. But I'll not go too much into detail because each of these subjects are a huge deal in themselves. I'll just try and give you a small overview so that you get an idea of how things actually go around in civil engineering. So civil engineering is basically everything related to construction. Everything that you see is being built or has been built is civil engineering. So that's why, as Gandhi sir rightly said in his note, that civil engineering is called mother of all branches, because if you have made anything and it is there, I mean, it was there, it served its purpose, then that was civil engineering. Even if the guy, maybe 2,500 years ago, if he didn't know the civil engineering principles, but still he was somehow able to make this structure, serve its purpose, that was civil engineering. And in the last 200 years, I would say, civil engineering has come a long way because of the development, the industrial revolution and everything. Civil engineering, when, if I talk about like 1500 AD, things were being built. Bridges were also, I think, were being built, but they were not really sure of the civil engineering principles and ideas that was behind. They knew some of the techniques, and you will see that some of the structures are still standing, but that's because they knew some basic techniques, but they couldn't really go further ahead because it required more research, more development, which has happened in last 100 odd years, and that has made this field even more interesting. So civil engineering basically comprises of, I've tried to come up with some of the fields. There are some more, but because we have limited time, I'll just try and rush through these. And if you have any questions, you can ask me later after my slides are over. So first field is building structures, which we all know, which we all always come across. Our home is one of the civil engineering structures. The buildings, the colleges, the hospitals, they are one branch of civil engineering, which is basically building structures. Then comes the infrastructure. We are all aware of that as well. The bridges, roads, highways, flyovers, railway tracks, even railway terminals, they are also part of infrastructures. Airports also come in infrastructures only, but since airports are a specialized structure, I named it separately. But please bear in mind, I have put these names separately because these require separate specialization. For example, I am a structural engineer in building structures. Now I can't go and design a bridge now. I mean, I know that the same civil engineering principles are involved, but I'll have to have at least a 7-8 months, 1 year of, learning curve. And then maybe I'll be able to produce a drawing which can actually be built on site. So I am a building structural engineer now. I'm doing buildings, I'm doing high rise, I'm doing low rise, I'm doing steel building, but I'm a building guy. I can't do a bridge now. 10 years down the line, it's very tough for me to shift my career and go that way. Similarly, if a guy is doing, let's say, power plants, he can't come back and do a building structure. He will be a specialized power plants guy. And even in power plants, you have several types of power plant. If a person is doing hydroelectric power plant, I don't think it will be very easy for him to do a nuclear power plant, because the nuclear power plant has its own requirement. Hydroelectric power plant is a totally different story. So you see, civil engineering is such a massive branch that even if you go one way, it will be very tough for you to take a detour and go another way. It's so massive, and trust me, all of these are very interesting. If you have that analytical mindset, and even if you don't have an analytical mindset, but if you are a people's person, you can coordinate work with a team of 100 people. You are the best civil engineer. Whoever civil engineers I've come across on sites, you will find them the most, vibrant people. Because if a person is sitting on site, he has to, as Gandhi sir mentioned in his note also, that if a person is sitting on site, he has to deal with laborers, he has to deal with client, he has to deal with design engineers, he has to deal with his fellow engineers, with MEP engineers. There is so much involved with that. So, uh, civil engineering is a place where most of the people can fit in. If you do not know how to program, you're there. If you know how to program, you're there. If you're good in computers, you can be there. If you're not that good in computers, you can still be there. So it offers a wide variety of scope for people. Similarly, we have other structures like dams, canals, etc., which I've broadly termed as hydraulic structures. Then we have maritime and offshore structures. These are about the harbors, ports, and docks. And the offshore structures are basically, I'll come to that. I have a small picture of these. So offshore structures are basically for extracting oil, crude oil from offshore, from inside the sea. And then we have heavy industries, which are basically factories, plants, and places where cars are being built, where steel is being extracted, or steel is being produced, and things like that. Then we have geotechnical engineering. Geotechnical engineering is the study of soil, because at the end of it, all your forces, all your structure is going to go to Mother Earth. So the site should be able to take that load, should be able to support that structure on which has been proposed there. So geotechnical engineering again becomes a specialized branch, and people are doing specialization in geotechnical engineering, and then then that is a separate career path within civil engineering. Then there are some other unconventional fields also that people don't usually know until they join civil engineering. We have environmental studies, we have construction management. Then earthquake engineering goes hand in hand with building structures, but I have tried to uh, bifurcate it here, because there is also a lot of R&D happening in this field. And US and South American countries and New Zealand, they are pioneers in this. And in a country like India, where we have high earthquake zone, this has massive relevance. So that's why I wanted to mention it here in my slides. And then as I was actually surprised to know that we have a wind tunnel facility in our college now, and I'm happily surprised. So this wind has the wind tunnel, or the wind modeling, or the wind analysis, as a separate branch in itself. Once you go down that way, you can't come back. That is another story. So and all those big structures that I've shown, they are all wind load driven. Because when you are sitting on a structure which is 1200 feet from ground, imagine you are on the top of that terrace. The wind load, the wind force there is massive, and that has an impact on the building. So if there's a building like this, which is standing like that, and if there's a wind load coming, you won't realize the amount of that wind load, the amount of load that comes on that structure due to wind load, and that becomes detrimental for the structure itself. So it becomes important that we study wind behavior, and we see how that structure can efficiently take load so that the building design is economical. We have had so many cases here in which the amount of reinforcement or the amount of concrete that was put in a building was shot up just because there was a small problem in the wind forces. So it becomes very important. I'll just go quickly through each of these because I know we are short of time. So again, I'll just go slightly more into detail about these. So building structures, as I said, this is a conventional discipline of civil engineering. All of us know about it. There are a lot of bodies involved in this. First one is client owner, who is the main sponsor of the whole thing. Then we have architects who come up with the plans. Then we have structural engineer, people like us, who take those architectural plans and see how can it actually be built. And then we see, okay, how will it behave for the various loads, and earthquake load, wind load, people on it. And then we come up with the most efficient, we try to come up with the most efficient solution, and that becomes our drawing, and that is what will be built on site. And on that, the architects will put their the facade, and at the end of it, when everything is complete, that's the architect's design will be will be visible, but the structural engineering will be integral part of it. So we also require geotechnical engineers who will do the ground inspection. They will see what is the kind of soil, can it support the load, what needs to be done, what kind of foundation to be proposed. Then there are MEP engineers. MEP engineers, they are the ones who are doing all the piping, all the air conditioning, lighting. They are all heavily involved. And MEP and structural engineering, they are the, when you call a building engineer will always comprise of these two people. One will be the structural engineer, and one will be the set of MEP engineers who will be doing the mechanical, electrical, and plumbing for the building. Then there's obviously the contractor who's going to build the whole thing on site, and the contractor will require the skilled and unskilled laborers. Similarly, if I go to infrastructure, this is again a similar thing. This might or might not have architects. Believe me, there are architects involved in these projects also at some times. So again, these are basically government projects. I mean, there'll not be a private body who will be doing this. These are like 99% of times these will be government projects. And then you also require transport planners who actually study the traffic, who study what amount of traffic is flowing, what is required, how much lanes are required, and they go on for that study for a longer period of time. In some cases maybe 5 to 8 years, and then they come up with their road plan, and then that is what is built. Again, if it is a bridge, a flyover, structural engineer will also be involved, but he'll be a infra guy. He'll be like he or she will be like a person doing bridges. And then again, geotechnical engineers are required because you always are, as I said, all the load is going on Mother Earth, so you have to see that the soil over there is good for taking those loads. Then again, I mentioned electrical, mechanical engineers because you have lights and other separate facilities which are going with the road these days, so they are also required. And then again, laborers. Then power plants. Power plants, again, I am just trying to give you an overview because these are separate heads. If a person becomes a power plant engineer, he is involved in the on-site or he is involved in design. He will have that specialization, and then he may progress in career in the same way. So these are various heads. Again, I'm just repeating that. So now power plants are one of the most important structures in any of the country's economy, and these are mostly sanctioned by governments. Sometimes they might have a private client, but mostly they are government projects, and they are of massive importance. Imagine, I don't know if you remember, some time back, an earthquake came in Japan, and it hit one of the nuclear power plants over there. And it was a situation of massive panic over there. If you remember, it was, I think, 5 to 6 years back. I'm just trying to give you an example of how important these structures are and how important it is for the engineer to determine the aggressive environment in which might these structures might have to face. So you have to think of all the scenarios which may affect adversely on the structure, and then you go ahead and design it separate. I'm actually a design engineer, so most of my talks will revolve around designing, but designing is just one part of it. From conception to design to execution on site, that is a whole different story. So even the guy who's is executing on site, even he has a specialization in various heads, which I've been talking about. So again, coming back to this is a very important structure, and it requires more amount of planning, more research, and then these things come up. Same with hydroelectric power plant, same with thermal power plant, and same with nuclear power plant. And each type of these, like hydroelectric is different from thermal is different from nuclear. Each type has its own expertise. And again, in this also, I'm not going to list all the bodies involved, but they also have similar number of people involved. And one more thing, in each of these projects, in fact, the building projects also we are doing, we also have project management people who are there just to manage the project. Imagine the sites and the projects are so massive and there are so many people involved that the client actually wants a project manager over there, a PPM guy, or he or she, who is sitting there managing the flow of information between the all the people involved in the project. For example, there'll be an architect, there'll be an engineer, then there'll be a MEP engineer, then there'll be contractor, then there'll be client. So client gives his requirement to architect builds it, he gives his requirement to engineers, they build it, to contractor. Then again, if there's a change from client, if he's not happy, or if he wants a change, then again that information will flow. Then within these bodies, there is a lot of coordination required. I mean, you can't imagine the detail in which we go. Even a small opening that you see in your structure has been planned there and has been coordinated with a large number of people that we normally don't know are there and are involved. So there is also a project management perspective for all of these projects, right? Moving ahead, again, there is hydraulic structures, there are dams. These are again of very high importance. They also require a lot of planning, and they also require their own expertise, and a lot of people are involved to make these massive structures. When I did my 6 weeks training, I actually was trained on the Karcham Wangtu project in Himachal Pradesh. It was a JP project at the time. It has now been commissioned, I think, and it is with the government now. But it was a spectacular experience, I must tell you. It was brilliant. I mean, the sheer amount of people involved and the amount of work that was being taken, I was just thrilled to be a part of it. So I mean, it's the civil engineering is is very interesting. But again, if you have an interest in civil engineering, then now, these are one of the most difficult structures that are being built, but they are required and they are being successfully built and are being used. So these are the one that you see in the picture on the top. This is the offshore oil extraction plant, and this is built right in middle of the sea. And as you might or might not be aware, these are very difficult structures to pull off. Both for designing and site execution is a totally different scenario. But these are also being built, and then they also require a specialized skilled set of team who carry out these jobs. And maritime is basically ports, docks, and harbors. Shipyards and those kind of things, and they again require their own expertise and their own set of people. Then again, this is heavy industries. Heavy industries is factories, plants. This is separate from maritime. And a person who is doing heavy industries, who has been involved in building factories, might not work in offshore, because that's a totally different scenario. So again, this is also very important structure. All these steel production, car production, and all kinds of plants that you see, they come in heavy industries, and they again require a separate set of skill set. Geotechnical engineering, I've already talked about it. I'll not go into much detail, but I just tried to show you there with a picture that what geotechnical engineering actually means. So, you have to study the soil, you have to study what kind of foundation you're going to provide, and then you go ahead and build the whole foundation or build the whole structure on it. So geotechnical engineering is a separate branch for that. Then comes environmental engineering. I personally didn't know that this, when I joined BTech in 2006, I personally did not know that environmental engineering is actually a part of civil engineering. And so, study of the type of water, their quality, studying the type of the pollution level in rivers, and those kind of things come into this. We also, there are separate branches where they are doing constant checks on the industrial effluents, on the domestic sewage that is being dumped into the river, and they have a separate set of, I will not go into details of this, but they have some standards which have to be fulfilled before the effluents are dumped into the river, and the river, so that the river also sustains, and the factories and the these places can also work. So there's a whole branch of study which is dedicated to this stream, and this has a separate career path of its own. As you can see, once you get into this will not be like the conventional structural or civil engineering or building and execution type of thing, but this again is very important given the scenario where in today's scenario where the pollution is rising, global warming, and all those kinds of things are happening. This I'm very sure that environmental engineering is going to gain grounds as we speak. Moving on. Okay, so that was a small overview of civil engineering, and trust me, that is not even tip of iceberg. I've literally tried to sum up massive branches into 2 or 3 statements, which is a huge undermine on my part, but time doesn't allow for that. So moving on, my learning from JUET Guna. When I started, I think it will be the scene for most of you. I don't know, but I think people are much more aware in these times. But sorry, but at my time, when I joined civil engineering, I was not really sure of which path will I take. But thanks to the faculty over there, I think it became very clear to me that I want to be a structural design engineer. Right around second year, I think, when I studied structural analysis, I thought that, okay, this is my field. This is where I want to be. This is what I want to do. And I am thankful for all the faculty members over there who taught me in a way that it made it interesting to me. And I actually pursued a career in that. I'm sitting here in Dubai doing the same thing day in and day out. I don't know if the other faculty members are online. Gandhi sir is there. All those shear forces, bending moment curves. I'm still doing that, and I love it. So that was one of the things. And it is also important to mention that JUET had and I think it still has a futuristic approach. So we were not only doing drawing, hand drawing, because nobody does hand drawing now. It's all on computers. So we were taught the software which is required. We were taught AutoCAD, we were taught STAAD, and there are other software also which have come into market now. I'm sure JUET must have incorporated that into their curriculum as well. So that also gave me an insight, and then I got an idea, and then during the semester break, so there was a 6 weeks training, and then after the end of second year also, I went for another training on my own where I learned the structural engineering software called STAAD, and that also played a very important part when I actually wanted to go into design. And and if you see the point number 4 here, I have actually mentioned my final year project played pivotal role in shaping my career. This actually has happened because when I went from site to the design engineer and I said that I want to come into design, he said, "What experience do you have?" And I said, my 4th year project, my final year project in my college time was analysis and design of a 20-story residential building. So I actually know, I didn't say that I know everything, but I at least know much more than a lot of other freshers did. And that's because I had faculty members in JUET who helped me to go through this. And I also had my own passion. But what I'm trying to say is that JUET helped boost my passion and not suppress it. And I'm really thankful for that. This final year project, to date, I think that if I hadn't picked this final year project, I don't know if I would still land in the same place. So that's why I'm really thankful for the wonderful years that I've passed over there, and that has had a massive impact on my career. Moving further, why civil engineering? So in my brief talk and in Gandhi sir's brief talk, civil engineering is for everyone. You must have gathered that from the two notes, that civil engineering is for a person who wants to do a desk job, who wants to sit and design and do 9 to 5 office job. They call it a white collar job. And if a person does not want to be behind desks, and he likes to do things on site, and basically not being inside office, civil engineering is the best discipline for them. They can go ahead and build those structures. And civil engineering is still evolving. This development that has happened around us in IT and everything, so those fields have progressed. Civil engineering is slightly behind on this, because civil engineering is, being the most ancient branch, it has its own way of working, which takes time to come into effect. But in last 2 or 3 years, things have started moving rapidly. They're moving fast now with the new technologies that are coming in. Things are changing as we speak. So if you have a problem solving ability, and you think out of the box, you think that, okay, there are several ways of doing a thing, and you have that kind of intent, you can always come into this. Because for any structure, we face problems day in and day out, and we keep breaking our head on how to solve problems. And if a person has that kind of ability, this is the place for you. And as I said, this is going a revolutionary, this field is going a revolutionary change. For example, in last 3 to 4 weeks, I have now started learning programming. I don't know if you know Python script or not, but I have actually started learning programming, because that's going to be the next big thing in structural design engineering. We are now trying to automate designing. And if a guy or he or she, if he doesn't know programming, it's not that it's the end of the day, but I can surely see that in coming 10 years, things are going to change, and they're going to change fast and massive. So I'm just trying to tell you that this also is a very interesting field, and all the latest developments are happening in this as well. And at the end, I would just say, being a civil engineer, I have also worked in India for 5 years, and I've done a lot of freelancing myself, and I've done a lot of structures who are there, which are standing there. In fact, I designed one of my friend's home, which is a steel structure in Noida in Sector 50. And whenever I go back in Delhi and I go and I stay there, it feels great. I mean, I designed something and I'm actually living in it. So it gives you a great sense of satisfaction. There are some other structures which I've done in Delhi here. And when you are doing something in Dubai with a company like WSP, you are doing iconic structures which are going to be there for long. For example, those A4B4 tower, I think they are casting 57th floor over there right now. But when it will be complete, my son, when I'll take him and I'll show him that, see, I was involved in this structure, that will be a feeling in itself, I think. So that is what I take out from here. I love what I do. And it also gives me a sense of satisfaction. It serves the society, and it fulfills. I mean, if you have an interest in these kind of things, it will fulfill your passion, your desire to work. And I think that should be it. I hope I did not take too long. That's one of our, we had a barbecue session. That's my team in Dubai here. And with that, I'll thank all of you for giving me this opportunity to speak. If you have any questions, and if time allows, I'm here to answer.
Thank you, Rajat, for a nice exposure of the civil engineering to the new aspirants, guardian, parents, and the teachers. There are a few questions.
Yep.
The participants, they have asked.
I'll stop sharing now, sir. Yeah, please go ahead.
One of our, again, there, Shri Karthik Srivastava,
yep.
He was also the alumni of JUET. He has written in the question answer box that I am doing MTech Structural Engineering from IIT Roorkee.
Okay.
And a graduate from JUET.
Yep.
Looking forward to get a campus placement. Being a placement representative, I can tell you the companies are not responding.
Yeah. I know.
uh,
I know.
so what to do think about the COVID impact on design industry? That is his question.
Yeah. See, I think design industry, I would say, is one of the least hit sectors when it comes to COVID, the pandemic situation, because the most affected sectors are hospitality sector, transportation sector, tourism, and those sectors have taken a massive hit. I would not think that the design firms have had that much of a problem. The problem has actually arrived because the flow of money stopped. So the investors are not actually, going out and giving their money. They are not actually letting their money flow because the times are not right for that. So that's why, since the money hasn't stopped, so that's why some of the projects have stopped. But again, the infra projects are not stopping. The bridges and the highways and the roads are being built as we speak. In fact, most of these structures, for example, for me, this 4 months of pandemic situation has been the most excruciating time. I've been sitting 16 hours a day, and it was tough for us to take leaves, because what has happened is that since most of the work couldn't be done on site, they could be done on our screens. So we tried to do as much as we can. So I would say, in a nutshell, that yes, the pandemic has had an effect on design, on civil engineering, but it's not that bad as compared to other sectors. And it will, once, if I talk about India, it's growing quite rapidly over there. But I think we have already hit the rock bottom, and everyone, not only the students, not only the engineers, everyone has to will start thinking of generating money again. So once the money starts flowing again, things will start picking up. Yes, but it will take 6 to 8 months, and it's not that bad. I mean, if I we have had some major setbacks here as well, but given the scenario, I think they were still fine. So I think it's not going to be this time. This testing time is not going to last for more than 6 to 8 months. Once the number of virus affected people starts going down, things will start going better, and that will happen, as I mean, faster than we think. I think that's my personal view, by the way.
You are right, Rajat. Actually, for the country like India, the scope is, as I have referred in my starting talk, that the infrastructure requirement of India in the coming 5-6 years is very much large.
Exactly. Yeah.
Yeah, India is now the present government is now planning to develop in terms of the metros, the renovation of railways,
Yep.
high speed
Yep.
trains
Yep. Yep.
and flyovers
Yep.
and many more. So there are so many options definitely will come as the
Yep.
COVID will over.
Just to add to that, for a developing country like India, where the infrastructure is still not in place, I don't see that there's going to be any problem. The building field has a impact, because the real estate starts dipping, is one of the first indicators or that the economy is going down, if the real estate sector starts dipping. But that's a very small sector for civil engineering. The infrastructure, and there are a lot of things that are happening around in India, and there is a lot of scope in that. So if you do not only look at building structures, and if you maybe look at bridges, you still have a lot of options open, I think.
Okay, Rajat,
Yep.
you have appreciated our faculty members of GUET.
Yes.
So all are hearing you.
Oh, really?
So,
Oh,
yeah, everybody is hearing you.
here is a big thank you to everyone.
So I will convey the same, but actually they are all have seen you also,
Okay,
right?
very good. Okay.
Golia sir, if you remember, Golia
Yeah,
sir.
yeah, 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 yeah. Oh, very
Yeah,
nice. Is he there? He's to everyone who is listening. Golia sir was one of my co-guide in my 4th year project, which I talked about.
yeah, he requested you to share your experience, what you actually learned during your journey from GUT till now.
Okay,
It,
okay.
it is it is in it is the real learning actually.
Oh, that will be tough to like come up with 2 or 3 lines. But as I said, I had a, I like what I do. Structural engineering is what I always preferred. And I think I've been lucky in that. And I have done a lot of RCC structures for the beginners. RCC structure is reinforced concrete structures that we see everywhere. And then I've done a lot of steel structures. Steel structure is not very common that you see. They are basically factories and plants. And I got a chance to work for those as well. So I have expertise. I'll not say expertise. I have experience in both these structures. And after I joined WSP, I got a chance to work in big, massive structures, and I shared some of those pictures. So apart from that, I mean, in structural engineering, in a nutshell, I've done RCC structures, and I've done mid-rise to high-rise. When I say high-rise, the maximum that I've done is 78 floor structures, which is the DMCC tower. It was originally conceptualized by Thornton Tomasetti in the US. They were the concept engineers, and then it came to WSP, and we were the detailed designers of it. And that is just one of the projects that I've been a part of. Then we are doing a lot of work in Saudi these days. And apart from that, whatever we learned from JUET, it still is there. The concept from Mala ma'am, the concept from Gandhi sir, from yourself sir, from Golia sir, from Shukla sir, from Murari sir, it's all there. I mean, even now when I'm doing a bending movement, a shear force, somewhere I can hear in the back of my mind Murari sir, shouting on us that your bending movement is wrong, and I think I've been lucky to reach where I am right now. I hope that answers your question, Golia sir.
Yeah, sure. Why not? Because learning never ends.
Yeah, exactly.
It will go on. Yeah,
exactly. And just to add to that, just to answer the question of Golia sir, we are now actually at a very interesting point. We are also trying to bring programming into structural engineering. So we are trying to learn, Dynamo and Grasshopper, where we can automate most of the things now, because architects keep on changing their design, and with the BIM modeling, that is Revit and all, the flow of information is very fast these days. So you have to be on the tip of your toe. So that's why we are trying to automate a lot of things now. It's in a very nascent stage right now. Our US offices, our US and UK offices are doing actually very good in that field, and we are slightly behind, but we are trying to catch up. And that's new. I think that's the new big thing that's going to happen in structural engineering.
Okay. One participant whose name is not mentioned, he is asking how I can join your company after passing the civil engineering.
So what happens is our company doesn't go for campus selection. There'll be, we call it a graduate day, which happens in our Noida and Bangalore office. We have 2 offices in India right now. One is in Noida and one is in Bangalore. So you can, I mean, if you visit our WSP website, you can see that there'll be some graduate day happening. It happened, I mean, this is a extraordinary year, but normally it would happen around July. I don't know what's the scenario this year. So where we give chances to freshers to join our company. And as I said, the Noida office has, the offshore center for 7 to 8 countries. We have US, we have UK, we have Sweden, we have Australia, we have Middle East, South Africa, Canada, Singapore, Hong Kong, maybe 1 or 2 more. So you can get, if you're good enough, there'll be a proper test, interview and everything. There's a proper graduate day. So there are a lot of things that are happening. And if you're lucky enough, you get into it, and then you will be allotted one of these CRCs that they call, and then you can maybe take it up from there. For me, I actually started from a small consultancy. And yes, for people who are passing out now, here is a small word of advice, and this is from my own experience, and I think Gandhi sir, Golia sir, everyone will agree with that. It's better to start your career from small office than a big office. What happens is, in a big office, you become a very small part of a very big job. So you are doing just one thing and you don't know what's going around, right? And it will take very long time for you to actually build from there. But when you start from a small office, and that's where I think I've been very lucky. I started from a small office, and in a small office, you get exposure to everything that's happening in the office. For example, when I was there, I was also the IT guy for my office. All the software installation and those things, I took care of them. and I was happy doing them because it only helped me understand how these things also work, you know. And then I got exposure to everything. So when I joined WSP, I already knew many things that, you know, people who had 10 years experience knew. So it actually helps you to boost your career. So I know and it was the same for me also. I thought, okay, why shouldn't I join a big office? Why shouldn't I join a big office? I was also doing my MTech, so that was also one of the things. But I would say stop do in a work in a 2 to 3 years in a small office, learn everything, and then go to a bigger office. You will have more chance of doing better instead of directly jumping into, let's say, a company called WSP. You might not get the full picture and it'll be too late. I've actually seen examples where a very good engineer, or let's say 2 or 3 of them, couldn't really cope up because they somehow always became part of the smaller thing happening rather than the bigger picture. And 2.5 years down the line, the guy still couldn't couldn't catch the drift of it. If he had started from a smaller office, it would have been much better. And people who started from smaller office, including myself, we are doing much better than people who actually started from these big firms. So that's a small word of advice from my end.
Okay, Rajat, there is one more question from one of our student, is from third year.
Yeah.
Which type of software is currently used for designing analysis of structures?
Yeah, that is actually a very good question. In analysis, we are using ETABS. That is the most used software, and ETABS is the most used software around the globe. If I talk about UK, US, Hong Kong, any of these, they are using other softwares like RAM and ADAPT as well. But ETABS is the basic software. So it is important for you to learn ETABS. It is important for you to learn, I would say, Revit or Tekla. But if you can't, at least learn AutoCAD. So you should know one drawing software and one analysis software. So for analysis, ETABS, the CSI family, you know, these are the ETABS, SAP, and SAFE. They are from the CSI family. If you know ETABS, and if you want to come into buildings, then ETABS is your software. If you want to go to, let's say, steel structures and all, then STAAD is the software. 2010 when I started, STAAD was basically being used everywhere in India. But then when I joined WSP, they were using ETABS, and ETABS is what is being globally used. So I would say, if you get a chance, learn Revit, which is the BIM drawing software, which does everything in 3D. So Revit, if not Revit, AutoCAD at least, and ETABS and STAAD. If you know these two, three softwares, you'll do wonders. Don't worry. All the best.
Rajat, one last question.
Yeah.
It is again from our passed out student Ankit Jha.
Yeah.
And he is your junior also at DTU presently.
Oh, very nice. Okay.
He is doing MTech in hydraulic engineering. He is asking, what is the scope of hydraulic engineering in your company?
As far as I remember, we are not doing hydraulic engineering in Middle East. There's no question. We don't have that massive water body also. We only have seas. In US, I think in some of the Nordics region companies, I think Norway, Sweden, etc. They're doing, but we are not that big into hydraulic structures. We are actually more on, you know, infra, buildings, heavy engineering, these part. Because if you want to go for hydraulic engineering, there is this company called SNC Levelin, which is one of the pioneer consultants in hydraulic engineering. So you can maybe try your luck with SNC Levelin, and there must be because I'm not a hydraulic structures guy, so I'm not even aware of many of these. But even in India, I think in Delhi, there are some consultants who are doing hydraulic engineering. So I think if you just search a bit on Google or maybe Naukri.com, or if you talk around, you might get more, you know, information on this. But WSP is not that much into hydraulic structures. We are getting some projects in power and water as we speak, but it's in a very nascent stage right now.
Rajat, this is the last question. Sorry, actually, one participant is requesting for this question.
Please go ahead.
He is Mr. Arshad from Jabalpur. He is asking, give me some suggestion about the interior design of the building.
Are you a civil engineer? Is he?
I don't know, but he is from Government College Jabalpur is mentioned.
Okay. If you are, I don't know if you are a BTech engineer, because for a civil engineer, ID is a slight off track, because ID is mostly ID is interior design. It's basically taken care of by architects. And if you want to do interior designing, you will have to do some specialized courses, I think, for that. Or if you already are, because I am not an artistic guy, I can't really think of much designs. If you already have that interest, maybe it will be faster, it will be easier for you to learn. But from civil engineering point of view, ID is slightly off track, and you might have to do additional courses to get into interior design. There are a lot of courses available. You can check the architectural colleges site. There is one called SPA in Delhi, which is the number one college in architecture, if I'm not wrong. So that is called School of Planning and Architecture. That's the best, I think, in India. But you can start your search from there. You can see which colleges are offering what kind of courses in interior design, because only civil engineering BTech degree, if you have that, is not going to suffice. You'll have to do a additional course on that. I think that's what I think. Yeah.
Okay, thank you, Rajat. We will see a
Yes.
small video of JP University to just showcase the
Yes.
ambience, the culture, and the other facility at JVT, right?
Yeah. I'll be happy to see too. It's been long
Yeah.
since I went there.
Participant, please wait. By this video, we will share the feedback link and then we will end the session, right? So
Yeah.
watch this video. So, dear participant, I am sharing the feedback link. You are all requested to fill this feedback.
I'll just interrupt with a small hello to Somaya sir. I just saw your message, sir. It's very nice to see that you're here and listening to me. Thank you so much, sir.
All participants are requested to fill the feedback form through the given link in the question and answer chat box. So, Rajat, we will end the session.
Yep. It
Great.
was.
Congratulations and thank you for a nice session.
Thank you, sir. Thanks to you
Right.
to give me this opportunity to do this.
Yeah.
Thank you so much.
Keep sending your guidance to the juniors, right?
Yeah, absolutely. Yeah, I'll be happy to help. Thank you so much. Thank you, everyone.
Okay. Thank you.
Thank you.
Bye.